Scientists warn that the emergence of humanity was a stroke of sheer luck. Had the giant insects of the Carboniferous period not gone extinct, mammals would never have evolved and you would simply not exist. 350 million years ago, Earth was dominated by creatures beyond your worst nightmares. Giant dragonflies with wingspans of 70 centimeters, massive arthropods large enough to dwarf a human being, and spiders larger than basketballs. But what is even more chilling is that the force responsible for their extinction was the decline in atmospheric oxygen levels. Today, humanity is altering the composition of Earth's atmosphere. If oxygen levels were to surge once again, could that nightmarish era of giant insects return? This terrifying epoch is known as the Carboniferous Period, dating back 350 million years. You may not have heard of this name, but you have certainly utilized its legacy, coal. Indeed, the coal burning in your home is the fossilized remains of those massive forests from 350 million years ago. Earth at that time was a completely different planet. The sky was not blue, but a grayish-white because atmospheric oxygen levels reached as high as 35%. What does that imply? Today, Earth's oxygen content is only 21%. Those additional 14 percentage points transformed the planet into an incubator for monsters. According to data from the British Geological Survey, the atmospheric composition of the Carboniferous was vastly different from today's. High oxygen concentrations created the perfect conditions for the rise of giant insects. But why does high oxygen allow insects to grow to such immense sizes? The answer lies in their unique respiratory systems. Insects do not breathe through lungs like humans. Their bodies are permeated by a network of tiny tracheal tubes. Oxygen diffuses directly through these tubes, reaching every cell in the body. This system has a critical limitation. As body size increases, it becomes harder to transport oxygen to deep internal tissues. That is why modern insects rarely exceed the size of a palm. Any larger, and they would suffocate from hypoxia. But during the Carboniferous, the atmosphere itself was a reservoir of concentrated oxygen. Insects absorbed it voraciously, expanding rapidly, and growing to unprecedented sizes. According to computational models by paleontologists at Stanford University, an oxygen concentration of 35% could increase the efficiency of insect tracheal systems by over 60%. This was the primary driver for the emergence of giant insects. And thus, the nightmare began. First, the ruler of the skies, the Meganeura. Its scientific name is Meganeura, referring to the large veins in its wings. A 70-centimeter wingspan was merely average. The largest fossil specimens reveal wingspans nearing 75 centimeters. To put that into perspective, that is comparable to the wingspan of an adult golden eagle. But there is a fundamental difference between a dragonfly and an eagle. The dragonfly is nature's most efficient aerial predator. It can reach flight speeds of 70 kilometers per hour, hover, fly backward, and execute sharp turns in midair. Modern dragonflies have a hunting success rate of 95%, making them the most successful predators in the natural world. Scale this efficiency up to the Carboniferous era, and you will understand why your ancestors were forced to hide in the mud. The compound eyes of the Meganeura were composed of nearly 30,000 ommatidia, providing a field of view of almost 360 degrees with virtually no blind spots. Its mandibles could extend in 0.03 seconds, 10 times faster than the blink of an eye. Before you could even react, you would already be trapped in its jaws. Its diet was diverse, including other insects, small amphibians, and even early reptiles. Nothing was safe. French paleontologists discovered a fossil site containing a massive accumulation of Meganeura wing fragments. They were densely packed, resembling the aftermath of an ancient aerial disaster. The sky belonged to them, but the terror in the air paled in comparison to the nightmare on the ground. The absolute ruler of the land was Arthropleura, reaching lengths of 2.6 meters. To visualize that, it is half a meter taller than basketball player Yao Ming. Its body consisted of approximately 30 segments, with a pair of legs on each side of every segment, totaling more than 60 legs. These legs did not move randomly, but rather precisely coordinated like a wave, allowing this colossus to move at astonishing speeds. According to fossil footprint analysis by the University of Manchester, the locomotion speed of Arthropleura could have reached 8 kilometers per hour. You might think 8 kilometers is not fast, but imagine for a moment a segmented creature over 2 meters long rushing towards you at a jogging pace. What would that feel like? Even more terrifying is the fact that scientists are still debating what this creature actually consumed. A study published in the journal Geology in 2022 found within the gut contents of an Arthropleura fossil traces of plant spores and woody fibers, but also skeletal fragments of small vertebrates. This implies it was likely omnivorous, consuming a wide variety of food sources. Giant scorpions reached lengths of nearly 70 centimeters, with stingers on their tails the size of daggers. Although fossil records of giant spiders are incomplete, estimates based on leg fragments suggest they were at least twice the size of the largest modern spiders. Then there were ancient millipedes nearly 3 meters long, moving like small tanks, crawling slowly across the forest floor. A paradise? Earth at that time was not a paradise for animals. It was a slaughterhouse dominated by arthropods. Meanwhile, your ancestors, the early precursors to mammals, spent their days doing 3 things: hiding, concealing, and fleeing. They dared not venture out during the day because dragonflies patrolled the skies. They dared not emerge from the ground for fear of encountering a 2-meter-long centipede. Their only survival strategy was to become smaller and more inconspicuous. For a full 50 million years, they remained the most lowly existence on this planet. But the question arises, why were oxygen concentrations so high? The answer lies hidden in the coal beneath your feet. The Carboniferous was a golden age of rampant plant proliferation. A warm and humid climate allowed vast forests to cover the land. This was the peak era for ferns. But these were not the diminutive ferns we see today. They were towering giants, capable of growing 40 to 50 meters tall, equivalent to the height of a 15-story building. Their fronds were immense, each leaf acting like a miniature oxygen factory, continuously absorbing carbon dioxide under the sunlight and releasing oxygen. According to climate model projections, the amount of oxygen released annually by carboniferous plants was more than 1.5 times that of today. More critically, the Earth at that time had not yet evolved decomposers capable of rapidly breaking down these plants. Fungi had not yet evolved the ability to decompose lignin, and termites had not yet appeared. After plants died, their remains were not quickly decomposed, but piled up layer by layer in swamps, eventually turning into coal. Consequently, the oxygen released by plants continued to accumulate, driving atmospheric oxygen concentrations from less than 20% to soar all the way to 35%. This process continued for a full 60 million years. The Earth thus became a hyper-oxygenated environment, effectively serving as a petri dish for giant insects. But history is always full of irony. What killed these giant insects was not some heroic counterattack by mammals, but an environmental shift they could not comprehend. By the late Carboniferous period, Earth's oxygen levels began to decline. The reasons were complex: changes in plant communities, massive volcanic activity, and shifts in ocean circulation. And most critically, fungi finally evolved the ability to decompose lignin. Dead plants began to decompose rapidly, returning the carbon sequestered within them to the atmosphere. Oxygen production decreased and carbon dioxide levels increased. Atmospheric composition began to change drastically. When oxygen levels fell from 35% to 25%, those once dominant giant insects began to suffocate. This is not an exaggeration. According to physiological research from the University of Munich, the insect tracheal respiratory system experiences a drastic drop in efficiency in low oxygen environments. The larger the body size, the more oxygen is required and the faster death arrives. The wings of Meganeura could no longer support flight. Arthropleura found it increasingly difficult to sustain its metabolism. They were not hunted down, they suffocated. This mass die-off lasted for millions of years, finally concluding during the late Permian, 252 million years ago. It marked a definitive end. That mass extinction event wiped out 96% of marine species and 70% of terrestrial species. The era of giant insects ended quietly, and those small, rat-like ancestors hiding in the mud could finally emerge from the shadows. You know the rest of the history. Dinosaurs rose while mammals lay dormant. An asteroid struck Earth, and mammals seized dominance. Finally, you appeared. But the prerequisite for all of this was that collapse in atmospheric oxygen. If that collapse had not occurred, the descendants of dragonflies would have continued to grow, and mammals would have remained pitiful creatures at the bottom of the food chain. You can stand at the apex of the food chain scrolling through videos, not because of your own superiority, but because the atmospheric composition of 350 million years ago saved you. Some scientists jokingly suggest that if oxygen levels were to return to over 30%, insects could evolve to giant sizes once again. In that scenario, the cockroaches in your home could grow as long as your arm, and mosquitoes might be the size of sparrows. This is a joke, of course, But what is not funny is that our control over this planet may be far weaker than we imagine. On a geological timescale, humans have existed for merely the blink of an eye, while those giant insects ruled for 50 million years. Who is the true master of this planet? It may not yet be time to answer that question. Now look down at your feet. Is there a cockroach or an ant crawling there? You could crush it with a single step, but you must realize their ancestors 350 million years ago were likely thicker than your arm. It was the change in atmospheric composition that subdued them for you. And regarding atmospheric composition, every liter of gasoline you use, every kilowatt hour of electricity, every lump of coal is quietly altering it. The giant insects of the Carboniferous spent 50 million years proving a universal truth. On this planet, there is no eternal ruler. When the environment changes, the deck is reshuffled. Just because you stand at the top of the food chain today does not mean you will be there tomorrow. So the question arises, if 350 million years from now, another intelligent species excavates our fossils, how will they judge us? This species that frantically altered the atmospheric composition, will we become the next giant insects to go extinct due to environmental change?